Senator Carper helping us and being interested in what we do. Anna Inter-Nicola is a former graduate student. Alan Mason's a current graduate student. Taylor Hoffman there was an undergraduate and then a technician in the lab. Julia Fontana is a graduate student, and then many other undergraduates and graduate students who've helped out. And myself am one part of this. I'm a biologist by training. I've also am working very closely with Tobias Kukulka, a professor at University of Delaware, who's a physical oceanographer, and Professor Helga Huntley, who is also a physical oceanographer, and Tracy DeLiberty, who's a geographer and GIS expert. So she's also working with us. So it's a big team, and I'm just sort of talking about what we've done on behalf of the group. So the next slide, Kate, please. So one thing I think is interesting in this group, I suspect is well aware of this, that we've had a post-World War II surge in plastic production. And so I like to think about the movie The Graduate. So it came out in 1967. So there's this enigmatic scene in The Graduate where you have sort of the future is plastics, as you've probably seen. And so, I mean, it's pretty good advice. The future really is plastics. You look at that exponentially increasing curve. So we're looking at global plastic production by industry. And so each of the different colors represents a different industry or use of plastics. The big pink at the bottom is packaging. And then there's also information in here on the lifetime of plastics. And it's kind of interesting to look at, some of these are, many years. Others are just a handful of, less than 6 months for packaging. And in fact, the sandwich that you might get that's wrapped in plastic, you unwrap the plastic, that plastic in your hands is on the order of minutes, maybe, in terms of the useful lifetime of that plastic. And so sort of some back of the envelope kind of numbers. About half of the plastic ever manufactured would have been made in the last 15 years if you sort of look at this exponential curve. And you see that disposable packaging is certainly a major use of plastic itself. And again, this is not anything new. But one thing I like about this kind of information is it shows that this is kind of a modern issue. And so it's something that we're just starting to get our hands on. It's not a sort of an old historic pollution problem. It's a new one. And the next slide, please. There's been some interesting sort of very large scale analyses of what happens to plastic, all that plastic that's been produced. And if you think about the global production of plastic and then what's happened to it, the blue arrow on the left is the production of plastic from 1950 to 2015, millions of metric tons or what the numbers are, but that's not terribly important. But if you follow that arrow over to the right, what it's showing you is what's happened to that material. So about 29% of that plastic that's ever been produced since 1950 is in use. And it's either in use in what's called like a primary stock, so that is, it's been manufactured and it's currently in use, or it's been recycled and it's in secondary use. So that's about 29%. But if you look at over on the far right, 55% roughly of that plastic has been thrown away, discarded. About 9% has been incinerated. And so, the over half of that material has gone out of the system. It's not being used. And what's interesting to me as well is a relatively small proportion is sort of caught in the recycling loop, about 7% of that plastic. So I think this just gives you a sense of sort of where the material is. The bulk of what's been produced has been thrown away or burned. So one of the things with plastic that we've really focused on is the micro side of plastic. And so microplastic is thought to be the most abundant plastic debris in the marine environment, which is where my work is focused. About 5 millimeter size particles or smaller is the cutoff limit for microplastic. At the low end, there's a debate among the research community about what's the lower limit of microplastic. Is it 1 micron? Is it 100 microns? So is it 300 microns, which is what a lot of people that use nets have set their nets to. So it just depends. But 5 millimeters is sort of thought to be the upper size limit by definition for microplastic. And one thing that's been interesting from a global perspective is that if you look around at beaches, you look at the sea surface, in the water column, you look at Arctic sea ice, you look at deep sea sediments, you go to the Pyrenees Mountains, there's plastic everywhere at this micro scale, which is kind of amazing and it's kind of disconcerting at the same time. So, so to think about that. Let's go ahead to the next slide, please. And so one thing that I think has been a little a little sort of misconstrued in the plastic issue is we see images of floating garbage patches, and it's tempting to think that that's sort of the main plastic issue in the ocean. But the reality is all that material breaks down and into these small pieces. And so from a sort of a marine perspective, thinking about the ocean at least, you really are probably better off thinking of the ocean instead of sort of this um, soup that has big sort of floating croutons in it that are your garbage patches. You're really thinking about like a really thin soup with lots of little shredded material in it. That's kind of the ocean with plastic. It's not about the big chunky stuff necessarily. There's just a lot of little stuff that you can't see that's in the water. And so that could be at the surface. It could be in the water column. It could be in biota. It could be at the seafloor, and going through various degrees of fragmentation. You'll also notice on the coastline there's a lot of little speckling that's representing plastic. And so that's one area that I think is sort of just coming to the fore, is how to think about the coastlines and how the coastlines are interacting with the water as a source and a sink of plastic. Let's go to the next slide, please. And so, yeah, you can go ahead and start that left animation. Thanks. So we have done two main things with how we've looked at plastic in Delaware Bay. One has been observations from boats, and this is our research vessel, the RV Daber, and we have a drone sort of sitting above the boat during this, taking these pictures. And what you can see, there's the boat, and then dragging behind it is a net. And so we're net sampling for plastic. And over to the right, you can see this sort of aggregation of material. Oh yeah, not the video. I'm just still in that first left-hand video, Kate. So just to the right of the boat, you can see sort of some foam and things like that. And so one of the things that our work has realized is, as you'll see, is that there are areas where material seems to be more aggregated than in others. And so that's something that's going to come back. And you can see it's these kind of areas, these tide lines that seem to have a fair amount of material. So let's go to the computer simulations. Thanks. And so one of the other things we do is we take the physical oceanography skill set that my colleague Tobias Kokolka and his students have and apply that to try to understand how particles that would be plastic move in the Delaware Bay environment. And so what you're seeing are particle concentrations of plastic. That's that color bar, the blues being low concentrations and the yellows being higher plastic concentrations. And what we're doing is we're taking little marine organisms, and those are the red dots, and letting them move within this field of plastic and try to understand how much plastic they experience over their lifetimes as they're sort of moving through the plastic field. And we've done this a couple different ways, as you'll see. Right now, I'm showing you sort of little red dot animals moving in the plastic field. We've also just sort of covered the bay with plastic in the computer and let the plastic move around where it goes. So this kind of work requires an understanding of the physical oceanography and then how to model that in a computer to understand the particles and their fate and distribution. Let's go to the next slide, please. So what have we learned? So now we have a quiz question. So Kate's going to run the quiz question, I think. So what I'm interested in is we've measured plastic at a lot of different places. And so I want to know if you think that the plastic concentration is higher in Delaware Bay or in the tidal rivers that feed the bay, like the Murderkill River and the Christina River and places like that. So is the concentration higher in Delaware Bay or the tidal rivers that feed it? Do we have answers, Kate?
Yeah, we've got about 80% of the respondents have said the tidal rivers feeding the bay and 21% the Delaware Bay.
Okay, so let's go to the next slide. So yeah, so most people say the tidal rivers, and we've got a few in the bay. Okay, yeah. So we can close that. Great. And next slide. So as I mentioned, we've been doing a lot of sampling in Delaware Bay as well as the tidal rivers. And so our sampling is focused sort of in the lower Delaware River, which you'll see sort of the up to Wilmington Delaware Memorial Bridge. And we've focused a lot on the St. Jones and Murderkill Rivers in the Dover watershed, as well as Delaware Bay itself and Rehoboth Bay and Indian River Bay, as well as the coastal ocean. And so the way we do this is we often tow nets or we pump water or we grab water. And then we take that and we digest the organic material. We break down all the little organisms and the pieces of marsh grass and things like that. And then we make the water very salty. And that floats the plastic to the top. And then we recover the plastic from the top. And then we look at what the plastic is. Is it, what polymer type is it? What shape is it? A fiber, a fragment, a bead, things like that. So if we go to this next slide, this will get us at our question. So tidal rivers, it seems like, actually have higher concentrations than the bay itself. And so these are pieces per cubic meter. And I have a graphic in a little bit that'll put that into a little bit more context for you. So about 3 pieces per cubic meter in the lower Delaware River. St. John's and Murderkill around 4.5 pieces per cubic meter. Rehoboth Bay, Indian River Bay, about the same, about 3. Delaware River, though, is 0.7. So we see the idea, I think, to think about is you have higher concentrations coming in from the tributaries, which get diluted in the bay and moved around and eventually ejected out. So we can go to the next slide, Kate. So one of the things that we do quite a bit of is try to understand what types of material we see. Are we looking at fibers or fragments or beads? And so here I'm just going to compare Delaware Bay to the rivers as well as the Delaware inland bays. So one thing that we see in Delaware Bay is we see more fragments, particularly in the upper bay, and fibers as well, but a little bit less fibers. Whereas in the rivers and the inland bays, we see more fibers and a little less fragments. And so this probably has to do with how the different materials aggregate and what floats and what sinks. But so we do see some differences between the bay and the rivers. You can go ahead to the next slide. The other thing that we're interested in is the chemical composition of the plastic. What polymers make up the plastic? Is it polyethylene, polypropylene? And for that, we use this instrument, which is called a Fourier transformed infrared spectrometer. And so it's basically, it just shines a light beam on the plastic and it measures how that material interacts with the light. And based on that, we get a fingerprint or a signature of the different plastic polymers, and we can use that to determine what type of plastic it is, or if it's not plastic at all. And so what we see in Delaware Bay is that of the plastic we get, most is polyethylene and polypropylene. And if we look at the rivers, again, with more fibers, we're seeing more textiles. We're seeing polyester and we're seeing rayon, in addition to polyethylene and polypropylene. And this is pretty consistent with other studies that have looked in other estuarine systems as well. So this seems to be pretty uniform. The next slide, please. And so these observations that I have talked about are really point samples. And what we want to be able to do is to try to use computers to help us fill in the gaps between these point samples. And so what my colleague Tobias Kukulka and his student Alan Mason have been doing is making these great computer models where you have basically a layer of buoyant plastic that's spread over the bay and allowed to float in whichever ways the currents and waves push that material. And one thing that you see is that the distribution of the plastic across the bay is not uniform once the winds and the waves sort of have their way. Rather, you have these sort of aggregations of material. And so what you see on the left in this little looping video is there's this red layer of plastic material, then the model starts up and the wind and waves move it around, the tides are coming in and out. And now if you look on the right, what you see is the concentration of that material, because when the little red dots overlay each other, you can't see that, but you're seeing sort of a reddish color on the right graph. And that's where you have the highest concentrations of plastic. So the plastic is really sort of aligned in filaments along the bay. It's not just evenly distributed as this sort of homogeneous soup, but rather there's places and times where you have more material and places and times where you have less. Okay, we can go ahead to the next slide. And so this is the comment I just said, basically. It's not this homogeneous plastic field in the bay, but rather there are hot spots. And those hot spots tend to be where you have saltier and fresher water mixing at what we call fronts in oceanographic terminology. And so it's those mixing of the two that seems to be trapping the material. Okay, the next slide. So I promised this before. So this is a person standing inside a cubic meter to give you a sense of what what this is. So I mentioned that we have sort of, less than 1 to about 5 pieces per cubic meter. Even that concentration exceeds open ocean garbage patches. But if you look at the effect of these aggregations, these tide lines where the material is aggregating, we can go to the next slide there, Kate. Um, there are areas where concentrations are about 100 to 1,000 times those values, and so now you're starting to see sort of more and more pieces per volume. So so that's what we sort of come to, is that we have these plastic concentrations, but when you just go out and sample them with a net, you're just getting one little spot. You need to think about the bay as being a dynamic system. Okay, the next slide, please. So one of the other things that we've worked on has been microplastics in blue crabs. And so when you think about that, one of the things that we want to know is how much plastic is coming into um, oh, so there's a kind of a comment in the chat that about plastic being introduced through research. Is it retrieved? So all that plastic that was on those videos before is all just in computer world. It's not actually releasing the plastic. It's all just a computer simulation. So we are planning a project where we're releasing material and following it, but those are inert bamboo cards that break down. So if we were to release anything for the research, it wouldn't be plastic. It would be a tracer that would either be a dye or a small piece of plant material. So microplastics in blue crabs is something that we're very interested in, and so we wanted to know if you have blue crabs in our tidal rivers that are ingesting microplastics. And so the place you have to think about, you got this animal, so where might you look for plastics? Well, one obvious place is to look in the stomach, because if the animal ingests the material, it should end up in the stomach. Another possibility is in the gills, because the animals are pulling water over their gills, and the gills are sort of meant, they trap material all the time, and they have ways to clean the gills off. And also the digestive cecum, which is like the hepatopancreas, the liver of the animals as well. And so we've collected crabs, we've dissected them to these different tissue types, and looked at the particles that we recovered, looking at their shapes and their polymer types, just like we talked about before. So let's go ahead to the next slide. So sample locations for this have been Blackbird Creek as well as the Murderkill River. These are two places that the DNREC Delaware Coastal Programs Group collects fish routinely. So Blackbird Creek is meant to be sort of a more pristine reference site, and the Murderkill is a more impacted site. So we can go to the next one. So for this, we process the samples, we dissect out the tissue, we take all that tissue and we digest it with a chemical so that it breaks down the tissue, and we're left with the plastic materials. And then we look at that under the microscope and then use the spectrometer I talked about to figure out the plastic polymer. Then next slide. So what do we find? If you look at the digestive cecum, the gills, and the stomach, you're going to notice that that bar on the far right is much bigger than the other bars. And so you're also going to notice that there's a lot of light gray color and not all that much dark gray color. And so we're looking at microparticle count, really, so you can think about it as the microplastics in those different tissues. And the light gray are the fibers, the dark gray, almost black, are the fragments. And so what we see is that about half, 48% of the crabs that we sampled had plastic in them. Predominantly that was in the stomach. So by far, we saw the most material in the stomach, and most of what we saw was fibers. So we weren't seeing fragments, we were seeing fibers. So fibers in the stomach in about half the crabs we sampled. Next slide. And if you look at what types of materials those are, polyester and rayon are those two fibers are the most common things to find in the stomachs of blue crabs. Some other things as well: nylon, acrylic, polypropylene, rubber. The crabs that had rubber in their stomach were all from a station that was just adjacent to Route 1. So presumably that's tire wear rubber that we see. Next slide. And so to summarize, yep, we do see plastic. It's mostly in the stomach, and it's mostly fibers. And next slide, Kate. And yeah, I guess just to finish for me before transitioning over to Kate, is that we have a website underthescope.udel.edu that has work on a lot of our sort of marine science work that we do, not just plastics. And it has lesson plans and various resources for plankton, which are the organism group that we focus the most on, including a microplastics lesson. That is, I'm not sure if the most recent one is available up there, but it uses data from our project, and it's geared towards elementary school students. Is that particular microplastics lesson plan? If it's not up there, then it should be up there soon. So with that, I think I'll hand it over to Kate.
Yeah, and I think we can stop for questions.
Oh, yeah.
If has any questions for John. It looks like, let's see if there's any in the chat, and you're welcome to leave some in the chat. So someone asked, surprised that plastic is introduced into the bay. Is that okay? So John already answered that question. So if anyone else has any other questions, you can unmute yourself or type it into the chat. We'll give you a moment. And then you also, if something comes to mind after my presentation, there'll be more time for questions. All right, so I guess I'll move on then. And again,
Oh, it looks like there's one question.
Oh, I went too fast. So John, are you planning to remove these plastic consolidation? I guess I'm not sure.
Yeah, I don't. Do you maybe want to unmute yourself and ask it
Sure.
again? Yeah.
Sure. So when you come across a large collection of plastic,
Yep.
I realize that it sort of acts as a magnet for other, but meanwhile, are you going to remove it?
Right.
To take it out?
Yep. So yeah, I understand. So what we've focused on has been helping to identify locations where some sort of remediation strategy that would be geared towards that would be best located. And so what I didn't talk about today is a GIS, geographical information systems analysis, where different land uses are being mapped across the watershed by our group, and also plastic production and various waste management locations as well as practices. And so what we're trying to do is to try to figure out where those sorts of efforts might be best placed, and then work with the state to maybe implement that in another project. And so I think that most of what we're finding in the Bay, it probably wouldn't be terribly efficient to do it that way, but stopping the material from coming in at the land is sort of where our thoughts are at the moment.
I just have a comment, I guess. I mean, it's amazing what you covered, John, and the comment you made about the crabs with rubber in them and Route 1 being nearby, and you think it's coming from tires. It just makes me think, I'm sure everyone has possibly seen, Facebook posts or whatever about some people out there around the globe are trying to find actually uses for used tires. And one of the uses they've come up with is to grind them all up and put it in road beds, like embed the rubber into the asphalt. And I just think that's, I always respond, that's a horrible idea. And what you just said a few minutes ago is like a perfect example of that. And so I don't know what the solution is for tires, but I don't think it's that. So it's pretty scary, actually, that I mean, I think that's part of the chemical industry is trying to find ways to perpetuate the use of plastic rather than, and obviously we're never going to get rid of plastic completely. It serves its purpose, but we do, they're trying to ramp up plastic production while we're trying to at least make it kind of rein it in for the uses that we, the single use is what, not that a tire is single use, but you know what I mean? Like we have to stop it, the proliferation of it going out into the environment. So anyway, sorry to ramble. I just had that observation.
And the tire wear is an interesting one because it's also been found in other systems too. In Charleston Harbor, there was a lot of tire wear particles that were found. They've been found in fish in that area as well as in the West Coast. So that's becoming more and more out there in the literature.
All right, well, I don't see any other questions. So
Can I ask a question?
Oh,
If
sorry.
if rubber, can I ask a question? Sorry, if the rubber's ending up in our waterways and stuff, that means the rubber breaks down. So can't they just use the tires to make new tires? Not that you know the answer necessarily, but
I don't particularly know the answer.
I don't know if they can, Cheryl. We should look into that. I honestly don't know, but hopefully they're doing something with them all. Other than putting it into the roads.
All right. Any other questions or thoughts? Okay. I'll move on, but I'm sure maybe some additional thoughts will come up at the end. Okay, so I'm Kate Fleming. I'm the coastal ecology specialist at Delaware Sea Grant, and I want to thank Dee for hosting us today to come and speak to all of you for Plastic Free Delaware's Lunch and Learn. I really appreciate that, and I also want to thank John. John's been doing these sessions with me over the past year. This is for a project that had originally been designed to be doing some outreach at fairs and festivals, and so with the pandemic, we've had to pivot, and he's been along the ride for me. Really appreciate that, John. So what I'm going to be talking about today is just building off a little bit of what we heard from John's research to talk about microfibers specifically as it relates to the topic of domestic laundry. And so just quick recap of what we heard that John is finding in his sample. Fibers are the most common type of microplastic in Delaware's tributaries as well as our inland bay waters, with polyester and rayon being some of the most common fibers that he's finding in those samples. And again, even finding some of these fibers in the stomachs of local seafood. So polyester and rayon in particular are fibers that are commonly used to manufacture textiles that are used in clothing products. And it's well accepted and understood in the science that the effluent from domestic laundry is one of the major contributors of these microfiber emissions into our waterways. And so I am making a bit of an assumption that many of us are washing our clothes using a washing machine, whether we're doing that at home or at a laundromat, or we're doing it ourselves or doing it for us. So that's why I've chosen to highlight this issue today and talk about it. So I like to start with the basics and kind of go over what different fibers are that are used in the manufacture of textiles used in clothing. And they can be broken down into three broad categories where we have natural, synthetic, or semi-synthetic fibers. And so our natural fibers are based on plants and animals. They're not altered in the creation of those textiles. They break down over time, so they're biodegradable. And when we think about some of the sustainability issues with natural fabrics, we might be thinking about the farming practices. So for example, if a cotton farmer is using pesticides when growing cotton, that might be something we think about. And then our synthetic fibers are based on man-made polymers that often come from the byproducts of petroleum. And so these are our plastic textiles. They're based on fossil fuels. They don't degrade over time. And some other associated impacts might have to do with the impacts related to the fossil fuel industry. And then semi-synthetic fibers might be a little bit less common, although I don't know with this group if you guys are a little more informed on this issue, but our semi-synthetic fibers are also known as regenerated cellulose. And so cellulose is the basis of plant material. And so semi-synthetic fibers, regenerated cellulose is based on plants like the pulp of bamboo, but then chemicals are used to dissolve that plant pulp and then extrude fibers. So because they're based on plants, they do degrade over time, but then the kind of unique sustainability issues with this product has to do with the use of those chemical emissions and using the chemicals that are used to create the textiles. And so I'm going to pose my first poll question. Just curious to know, I always do the polls wrong. Stop share results. Here we go. Can you all see that? Nope, that's not it. That's the last one. Relaunch polling. I'm gonna have to start over because I'm polling. You would think I would get this.
There's a little drop down arrow at
There
the
is.
title. You got
There
it?
is. There is. I know how to do this, and yeah. So anyways, the question is, what type of material do you think your shirt is made of, or you can consider some other kind of clothing item? I've done these polls 100 times and they always get me. Yeah, so consider something you're wearing or maybe nearby, and just kind of start thinking about what we've all got going on. It sounds like I'll give you guys a minute to respond too. I'm gonna. Ooh, it's getting fairly even. Okay, so share results. All right, so most people are natural fabrics. We have some plastic and some rayon. All right, so the semi-synthetic, sometimes I think that's a little less common. Okay, moving on, Kate. Okay, so what does that look like on your tag? So again, this is probably fairly familiar, and I'm just trying to, we do get questions sometimes of what these different fabrics and fibers are. So our natural fabrics, this is not a comprehensive list, but of course, cotton comes from the seed pod of a cotton plant. Linen is actually created from the stalks of flax plants. So it's soaked and dried and then pounded to be created, to create that fabric. Silk comes from the cocoons of silkworms. Wool is sheared from animals like sheep and goats and even camels. And then our plastic fabrics, our synthetic fabrics, these will be familiar to you. So nylon was actually the first fabric that was created, synthetic fabric that was created for a clothing application in hosiery. And now we see nylon used in all kinds of stuff. It's a versatile product. Polyester is another really versatile textile. And it can look and feel very different, but I've chosen to highlight the microfleece because microfleece has been shown to be such a major emitter of microfibers in washing machines. I will talk about that a little bit later. Acrylic was created to mimic wool. Spandex and elastane are essentially the same thing, but they've got that stretch characteristic that makes them good for athletic wear and swimwear. And then polypropylene is sometimes used in clothing. It's a little bit less common, but if you have any kind of extreme cold weather base layers, you might have some polypropylene in your wardrobe. And then our semi-synthetic, again, the regenerated cellulose might be a little less familiar to some of you. These are essentially our rayons, and our rayons were created to mimic silk, so cheaper options for silk. And so you might see on your tag something that says rayon or viscose from bamboo. Anything bamboo is usually a rayon product. And then some of these other types, the modal and lyocell, have been created by the industry has recognized the issue with the chemical emissions. And so they've made some efforts to minimize those emissions. So they're kind of branded as a little bit more eco-conscious. And then we have acetate. And so I've got all these polls in my my presentations, so I have to learn. But I did it. So is the concentration of microplastics higher in Delaware? Oh, that's, geez, what the heck? So I think, okay.
Okay, it says 3. It says the third one, I think.
Yeah, but the question should be, take a look at your tag on your shirt and what type of material is your shirt made of. It looks like the options are still the same. If you want to give that some consideration. And honestly, this was just meant to be a little bit of fun to get y'all thinking about what you're wearing. So the question should be, take a look at your tag on your shirt and what type of material is your shirt made from, if anyone wants to play. Or did I already moved on, didn't I? All right, we're gonna stop with the polls, Kate. Oh my goodness. All right, so there has been a lot of interest by the industry as well as researchers to better understand fiber shedding in domestic laundry. And so there's lots of different variables that can be tested and has been tested to kind of look at this and try and get a better understanding of fiber shedding as it relates to domestic laundry. So some factors include the characteristics of the textile. So what types are we talking about? You know, we can talk about this in terms of synthetic and natural, but you can really drill down. There's different types of polyesters. The wear and age of those fabrics can influence whether or not the rate of shedding over time. The fiber lengths, there's actually short fiber and long fiber. And so these are things that aren't things that you as consumers or people that are acquiring clothes would really be able to discern from a tag. But this is the kind of information that the textile industry can use to hopefully inform the manufacture of textiles moving forward. But then there are other things like washing machine variables can influence shedding. Human choices can influence shedding. If I think about it, we all likely have very different washing machines, different years and models. There's a lot of different machines out there, and there's all of these different factors. So it can be complicated. It can be really, you know, and there's a lot of literature on this, and I had envisioned kind of going through the literature and trying to pull out best practices for folks that if you follow these steps, then you can minimize microfiber emissions when doing laundry. And I find that they're just really difficult to compare because there are so many variables. Just an example, there was a study where some scientists identified that top loading machines were associated with higher microfiber emissions, and other scientists were quick to point out that, well, that top loading machine also had a central agitator present, and maybe that relationship was a little more important. Not all top loading machines necessarily have a central agitator, so it can be complicated. But you know, there are still, I think, some things that we do know about this topic that we can use to inform our decision making. So first is just going back to that first assumption that we started this presentation with, which is domestic laundry is known to be a widespread source of plastic microfiber emissions into our waterways, and that all fabrics shed and will shed over the course of their lifetime. So that's whether or not we're talking about natural fabrics, synthetic fabrics, semi-synthetic. And so just giving some consideration perhaps to which of those are biodegradable, for example. And then one that is pretty consistent that we have seen multiple times in the literature is that microfleece, this type of polyester, is consistently identified as a high volume emitter of plastic microfibers into our waterways. So that's, you know, our lightweight outerwear is oftentimes a microfleece. I know in the pandemic, I have been wearing a lot of microfleece, I'm not gonna lie. And then there are also mitigation tools that can be used to minimize the emissions of microfibers into washing machine effluent. And that's not something I've talked about yet, but we're going to talk about it now. And so there have been a couple of studies that have actually tested the efficacy of some of these products, and I'm highlighting the one below that came out just last year, where they tested a number of these products. And so the first kind of broad category of these products I want to review are those that are meant to be used during the load of laundry, where they go in the drum of the washing machine. And so maybe some of you have heard of some of these products. The Cora ball is the only laundry ball that I'm familiar with that's on the market, but it's meant to be placed in your washing machine and capture microfibers kind of in these long tentacles to intercept them before they're able to go out in your wastewater. And then washing bags are another one where the Guppy Friend was created specifically for microfibers in mind. And so you place your clothes in that washing bag. And what this study actually found is that the Guppy Friend was the most effective of this type of product. And it seems that it works not by necessarily capturing the microfibers, but actually minimizing shedding, which makes sense. I think it's probably more gentle on your clothes. And with that in mind, it might actually increase the life of your clothing if it's reducing the amount of shedding coming from your clothing. And then this Fourth Element product that was tested, that's a brand. And so they had developed a washing bag specific for their clothing. And I don't believe that's on the market anymore if it ever went to market. But then the other type of products are these filters, washing machine filters. So we've got inline filters. There's a number of products on the market, and they're meant for at-home washing machines where they're installed on your water line. They're not appropriate for commercial use at a laundromat. And they were effective. The ones that were tested were effective in intercepting about a quarter to a little bit more of the microfibers that would have gone out in the washing machine wastewater. And then by far the most effective product was a prototype of a filter that is meant to be installed in the machine at the point of manufacture. And I believe there's a few kinds of filters like this out there. And where it's at here, as far as I understand, I just pinged the NOAA Marine Debris team to see if they knew the latest and the greatest. What I understand is that these companies are currently working with the washing machine industry to try and work with them to get these incorporated at the point of manufacture. And it sounds like France is actually currently making this a requirement that these filters will be installed on all washing machines that are going to be sold by the year 2025. So that's a little bit of an interesting development. I'm not familiar with any kind of efforts like that here in the United States, but it'll be interesting to follow and see how it goes and if any other countries end up doing something similar. And so overall, I think there's just a few things that we can think about in terms of what we know about fiber shedding from clothing and laundry. And so we can use this to inform our decisions about fabric choices when we're going to acquire clothing items for our wardrobe. We might consider our wash frequency. So I'm not suggesting that people at all stop washing their clothes, but you know, those micro fleeces are not right next to your skin, and so they might not need to be washed every time you wear it. And then perhaps consider the use of some of these, using one or several of these fiber catching products. So I'm going to skip this last poll question because it's painful for me, and we're going to move on. I just wanted to mention again that John's been doing these sessions with me over the course of this pandemic, and originally this was an outreach project that was going to be done at fairs and festivals. So I'm so excited to mention that we're actually transitioning to some exhibits later this month. Our first exhibit will be at the Horseshoe Crab and Shorebird Festival in Milton on the 29th, and folks that come visit us will have a chance to win some of these microfiber catching tools in a little game that we'll have set up. And actually for participating today, also some of you, I'm gonna reach out to some of you and say, yay, you're a winner. And so with that, anyway, so come see us if you want to get outside. Hopefully it'll be a nice day. And with that, if there are any other questions, maybe Dee will ask you to help with that.
I'm sorry, can you put the info about that event back on the screen for a second?
Sure. There you go.
I didn't know there were any festivals coming up. It's good to know that maybe we've started again being out in public.
We actually decided to go to this one with the kind of thought that it's probably going to be a little bit smaller scale and it's all outdoors. So we're just going to see how it goes. But we had been invited to go to the fair in July and ultimately opted for a number of reasons, maybe to skip that one. You know, those tents are sometimes very crowded. And also,
all right, well, we run a fairly informal ship here, so if anyone has questions, feel free to unmute yourself and ask, or you know, we can just have a discussion about what you've heard today and welcome everyone's thoughts.
This is Stephanie. I've got a kind of a question. You talked a little bit. First of all, both of you, great presentations. Thank you. This is wonderful information. You talked a little bit about the blue crab and just the types of microplastics and stuff that are found there. What are the implications for other seafood? And I ask this as someone who actually doesn't live in Delaware anymore, but we do support our local seafood. We've got a I forget what the name of the group is, but it's like a community seafood program. And I'm just wondering every week when I get my flounder, am I filling my belly with microplastics in the process?
Yeah, I think that most of the microplastics that's been found in seafood has kind of been like what we found in the stomach or in the gills, which are things that you generally don't eat. But also, I would say that the approach that we've been taking for analysis has been looking at the larger pieces of microplastic, um, but not what's termed nanoplastic. And it's those nanoplastics and very small microplastics that would have be the material that, if anything, would cross the gut barrier into perhaps the muscle tissue, it would be the smaller plastics. And so there's sort of a move to try to look more closely at those smaller plastic pieces. And so it's something that we're the sort of the routine equipment that we have in the lab doesn't work much beyond about 10 microns, which gets you into sort of the small microplastics, but not these sort of nanoplastics that could move into the muscle. The other thing that some people have suggested is that contaminants associated with plastic could be ingested and then be stripped off the plastic, and then that go into the fish itself. The research on that is a little less clear. So I think that's sort of the next frontier. So, you know, we have meetings pretty routinely of sort of the microplastic community, and that's the one question I think that people really want to get a better answer, is the smaller plastics and how it interacts with sort of muscle tissue, the things that we know people eat. So no good answer for you, but certainly at least there's no direct connection between what we found necessarily and certainly the muscle of the crabs that you eat, but there's plenty of reasons to suspect that if you had smaller plastic material or potentially materials that were to come off the plastic, that could be an issue.
John, and maybe in follow up to that, it just I'm sure you're familiar with you're probably much more familiar with it than I am, but the blurbs that I hear are that we all are eating a credit card worth of plastic a day. And also, that something like 99% of table salt contains plastic. So I don't know, if you know more about where that kind of data came from, but it sort of goes to Stephanie's question as well.
Yeah, I've heard that as well. And I don't know so much about the source of it. I didn't fact check that, but I mean, you can certainly inhale plastic. You can eat it with foods as well. The one aspect of your question, it just struck me, and then I think it went out of my head. But oh, I forget. There was another part of your question.
The credit card size that we're eating every day. That's the kind of meme that is out there.
Yeah, I think the one thing that surprised me was the aerosol plastic. So, if you have even plastic material that might come out of dryers. And so, Kate's talked a lot about washers and that getting into the water stream. But I think there's also some suggestion that, you can have plastic material coming out of dryers and that aerosolizes. And so it's hard to get at those numbers. But I think I've seen a few studies that have sort of tried to understand that dimension of plastic. And that's, that has to be the explanation for things like plastics in the Pyrenees, where, you get sort of convected on air currents. And so I think it's a complicated issue. And as we said at the beginning, it's one that's sort of increasing in plastics aren't going away. I mean, apart from the name of your organization, but I think the idea of production of plastics is that trajectory is pretty striking. The one thing I guess you could say too is in the little plot I showed, there were ticks where we had the recession. So we had the oil crisis, and then there was the recession. And so I'm really curious to see what happens with COVID, and if we actually go the other way and have a little uptick because of all the plastic that's being produced. I think that'll be interesting to look at.
Thank you so much for your answer. And just one final shout out. Actually, two things. I shared a photo in the chat that I pulled from Instagram. I'm not sure how accurate it is, but Plastic Pollutes shared it. It was just clothing fibers that are more plasticky and those that are less. But the other thing is I've been using the Guppy Friend for probably about 4 to 6 weeks now. I don't find that I'm getting a ton of fiber out of it, but I feel
No.
better using it. And I use,
Well,
I wear mostly yoga pants, so that they don't shed the way a fleece jacket would. So the fibers are going to be much smaller and much, much tighter.
well, and so what those researchers actually found is that they didn't believe that Guppy Friend was functioning by capturing more microfibers. They were reducing overall shedding in the first place. So your clothes are shedding less.
Yeah, that makes me feel good.
Yeah.
Thanks.
And your clothes might last longer too. I see another comment from Brian Moran with Delaware Surfrider. Is there a way for regular citizens to clean microplastics from our coastlines?
Yeah, I guess I can take that. The cleaning up of the microplastics, I think, is tricky. Sampling them is tricky. I think that probably the best way to deal with microplastics in the environment is to get rid of the macroplastics in the environment. And so probably cleaning up, because what's going to happen is that material gets broken down by ultraviolet light and by temperature changes and by salt exposure. And so to remove the macroplastic debris is probably going to be one of the more effective ways to get rid of microplastics in the longer term. And so that's one thing that we have a project hopefully that will start fairly soon that will try to understand the size distribution of plastic that we see, both micro to macro, to try to figure out, what are the pathways? Is it the beaches that are collecting the material and then sort of dribbling into the bay over time? Is it water, larger pieces of macroplastic that's brought into the bay through tributaries and then gets brought up to the shoreline to degrade and then come in as microplastic? But I do think that working on beach cleanups to get rid of the macroplastic is probably a more effective way than trying to sieve a whole bunch of sand or things like that.
I will also mention, I don't know if you've heard of Nurdle Patrol, but here, oh, I wanted to keep sharing my screen. But Nurdle Patrol, so nurdles, I'm sure you all are familiar, are the kind of raw material that are used to make all plastic products. And there is a program called Nurdle Patrol that began out of, it was a National Estuarine Research Reserve in Texas, where they are seeing lots of these nurdles washing up on their shorelines. And so there's this kind of citizen science effort to look for where nurdles might also be washing up around the United States in particular. So this is the citizen science thing. We've got a few spots where the green is no nurdles, but a few nurdles have been found along our coastline.
Kate, I don't think we're seeing your screen, or we are seeing your screen, but not that particular screen. I just see a big blue screen with your icons on it, like your main desktop.
Do you see it now?
Okay, there we go. Yeah.
Oh,
yeah.
I shared the wrong. Okay. Yeah. So this is Nurdle Patrol. So something it is a program out there, a citizen science opportunity, and you could consider that you can, if you want to look for nurdles and encounter them, you can submit data. And if this is something, I know I've looked for them a little bit and I don't find them in large concentrations on our beaches, but there hasn't been a lot of looking yet. The Delaware Coastal Programs has also been looking a little bit. So it would be interesting to know, not a lot of beach area has been covered in Delaware. If you encountered nurdles, it would be interesting to know, and you could submit the data and then it would show up on these maps.
Thanks. That's kind of where I was going with my question, because I know I'm visually challenged and I can't tell a nurdle from a pebble.
They look pretty similar. I was going to say those look like grains of sand, though, in Kate's picture.
Because we're doing like a beach cleanup this weekend and we pick up the big stuff, the foam cups and the trash bags and things like that. But it would be interesting if we could do a cleanup that's kind of focused on nurdles. But is there a way for someone to go through and get those without bending over and picking up each individual piece by hand?
I don't think so. You gotta kind of pick them up. And what I found is when I have found them, they're a little bit higher up on the beach, and I worry a little bit. I don't want to be approaching the dune area and trampling that area, given that I haven't come across really large concentrations of nurdles except for Deemer's Beach, which it makes sense because there was a historic Superfund site Deemer's Beach is up in Newcastle County, and there was a super fun site in the area. So I think there might be some remaining nurdles there associated with that cleanup that happened in the 90s. But for the rest of the state, I worry that the impact for them might be worse than the benefit of picking them up, given that they haven't seemed to be in large concentrations.
But what about using this as like a campaign item with DENREC to help people that are already going to parks and stuff? If they see it, take it out. And maybe also empowering them to pick up trash instead of these big cleanups, like do it along the way. I know I do it, but a lot of people just walk by trash sitting on the ground.
And I might mention that in our work with Plastic Free Delaware, we, every once in a while we'll get an inquiry about a beach cleanup, or, how can I help? I want to get involved. I want to do a beach cleanup. And in general, we don't do beach cleanups because, they're important, they're necessary. Thank you, Brian, for Surfrider. And I know like Delaware Surf Fishing does a weekly cleanup down at the shore, down at the beaches. And but our focus in our work with Plastic Free Delaware is to try to address the root causes of all that plastic going out there along our roadsides, being mowed up into little bits that then end up out in the marine environment, and all that plastic that's ending up out there to begin with. So that's our focus of work, to try to address the root causes and reduce single-use plastic usage. So just, so I just thought I'd put a plug in for, that's our approach. Thank you to all those who do clean up, but please help us spread the word. We work on our mission in two ways, basically educational programs like this and going to festivals like Kate mentioned and other educational programs. And then the other side is the policy work. We do have, I mentioned the styrofoam bill, Senate Bill 140 that was just introduced. We also have a bill this year that Surfrider and others have been partnering with us on to reduce balloon releases, which is another huge problem on the beaches and elsewhere and marine environments. And that's passed the Senate and House committee. And we don't really know why it hasn't been scheduled in the House for a full vote, because it's sort of a no-brainer. It's been has a ton of support all along the way. It's not really a controversial bill. So please reach out to your House member and ask them to support, that's HB 22 on balloons. And so those are the two bills we're really focusing on this year, again, to try to reduce the amount of plastic that ends up out in the environment.
Dee, I just wanted to add that the bill you called the Styrofoam Bill 140 also prohibits the distribution of plastic utensils and straws and cocktail picks and all those other little plastic things that are so easy to just get blown around and end up in the waterways.
True. Actually, that's great, Cheryl. Thank you. And it also bans if we can get it passed, we need everybody's help to get it passed, but it will also ban the sale of styrofoam packing peanuts and styrofoam cups, styrofoam plates. It will get styrofoam trays out of our schools, which our kids are literally eating off of styrofoam trays, which seems crazy. So it's a pretty broad bill, but vitally important, I think, to, styrofoam is really one of the worst forms of single-use plastic and is generally not recyclable and nor recycled. So everybody please help us with Senate Bill 140. That's just getting started. So any other questions out there or comments on
I don't have a question, Dee, but while you're talking about bills, I think I put in the chat that the Break Free from Plastic Pollution Act of 2021, if you can contact Chris Coons or Tom Carper if you live in Delaware and ask them to support that bill. Sorry, there's during construction here. Lisa Blunt Rochester has already supported this bill. I don't have the bill number right in front of me, but it's the Break Free from Plastic Pollution Act. And that is a very all-encompassing, a much stronger bill against plastic than any of the other bills out there. And one of the things that they have in that is to have all of the future washing machines being made have that guppy bag or whatever that thing that works well that you
Filter,
mentioned. The filter thing be in new washing machines being sold. But there's a lot of other good stuff in that bill as well, in terms of having extended producer responsibility and a lot of other good things. So look at that. And then if you could contact Coons and Carper to ask them to support the bill, that would be great.
And we hope to have a webinar specifically on that bill in June sometime. So stay tuned for that. Keep an eye out for that on
I have a
Facebook.
question. Oh.
Yeah.
It's very difficult to recycle textiles. And is there any information about where to recycle them? Like old sheets or curtains or whatever.
I don't have any information for recycling. I know some people do upcycling or, find reuses for things like that. I think about sheets, donating them to dog rescues, but that's because I'm a dog person.
Yeah.
They can also be made into bags, grocery bags.
Cheryl's leading a project of ours to convert old t-shirts to reusable shopping bags.
Oh,
So if
cool.
anyone, I don't know, Cheryl, are you still collecting t-shirts?
I
that
haven't
project?
been collecting. I haven't been collecting during COVID. I did donate about 600 to a local food pantry. I still have some more in my garage, and perhaps when COVID's over, we'll get started on that again. But I think the thing that Patty does would be more aligned with recycling sheets and curtains.
Yeah. Another one of our board members started a project taking leftover fabric, or like Cheryl said, draperies and whatnot, and sewing them into reusable shopping bags, shopping totes. So again, that was sort of put on hold because of COVID, but if anyone's interested in that, can get in touch with us, and that hopefully that project will get started again. And Judy, I just saw an article, the headline the other day about textiles. So I'll see if I can find that, and I'll send it to everybody if I can find it.
Thank you.
One of the some of you may know Babita, who has been on a webinar with us before, and I've asked her that question a lot of times, and it's not really her line of work. Like she takes clothing donations and the clothing gets reworn. But I keep asking her, well, then what do you do with all the stuff that is not wearable and it's sort of at the end of its life? And it's not something that she, I think, is focused on. So I don't know. I think it's a great question, and we should keep digging into that. Joelle says that some of the thrift shops take textiles to recycle them, I guess, or do they, what do they do with them? Do they compost them? I mean, what do you do when it's at the end of its life? Where'd Joelle go? Joelle, do you know? Are you trying to unmute? Let me see if there, try that.
I have didn't you have someone from Phoenix Textiles on a while back?
That's Babita, yeah. And I keep asking her that question, but I'm not, she doesn't really have a great answer because it's not what she does. So
and she was picking up linens from hotels
but her answer to me is that she always finds a home for everything to be reused. But my question is, what do you do with it when it's at the end, like when it can't be reused? Then what? Does it just go to the landfill? But some of that stuff is biodegradable, so it's a shame that it goes to the landfill. Joelle, I didn't know if you had more information.
Yeah, still figuring.
Yeah, well, you're unmuted now.
Oh, okay. Oh, shoot. Now I'm gone.
No, you're on.
Oh, okay. I'm sorry. I've seen them packaged in bundles, so I'm not sure what happens to them after that, but I'll check it out because I've always been interested in that. They
And
compress.
if, yeah, love to
wrap
have a
them.
speaker on that if we can find someone that is knowledgeable about that topic.
Right.
Great. Okay, well, I know I promise everyone we try to end by 1. I don't want to keep Kate and John too much longer. Does anyone have any more questions for them on microplastics and all the food for thought they gave us for today? All right, well,
Thank you.
sorry.
Thank you so much. It's been great. Thanks.
For having us.
Thank you. It was great.
Yeah,
Very
thanks so much.
informative.
And
Thank you.
Thanks,
we look
Dave,
forward
for
to-
putting.
Absolutely. Yeah, thanks everyone for being here. Thank you, John and Kate, and look forward to maybe having you back again to report on future research.
Thank you.
Thank you.
Seeing you at the festivals.
Yeah.
All right, thanks
Thank
guys.
you. Bye.